Greetings folks, welcome. This video we're going to have some fun in Excel making a histogram. So you might recall that a histogram is used to show a quantitative variable, and a histogram is actually a picture of a frequency distribution. And of course a frequency distribution tells you the values that a variable can have and the frequency with which those values are observed. When working in Excel, there are a couple things you have to keep in mind. First is that different versions of Excel are going to look different. I'm using Excel on a MacBook Pro, but if you have a PC, your version of Excel might look a little bit different. Also, there are different ways of doing things in Excel. The steps that I'm going to show you I think are good for a beginner, but a more advanced user might have some shortcuts to accomplish these same tasks. The variable that we're going to study is the wait time for the Space Mountain roller coaster at the Walt Disney World. As I mentioned a moment ago, we're actually going to start from a frequency distribution. And this picture right here actually just gives you an idea of the shell of what that frequency distribution is going to look like. So this first column that has a label of wait time will include the classes that we're going to use. So first we're going to have to figure out an appropriate number of classes. Then we'll determine the class width. And that second column that has a label of number of observations is where we're going to count the number of observations that fall in each class. The sample size that we'll be working with is 1141 observations. So the first thing we're going to do is find an appropriate number of classes. So we'll find the smallest value of k such that 2 to the kth power is greater than or equal to n. Again, n is our sample size of 1141 observations. And as it turns out, a k value of 11 actually satisfies that rule of thumb. 2 to the 11th power equals 2048, which is greater than our sample size of 1141. So we'll probably use about 11 classes. To determine the class width, you take the range of the variable, which is the maximum minus the minimum, and divide it by the number of classes. So the range for the variable that we're studying is 125, because the maximum value is 135 and the minimum is 10. So if you take 125 and divide it by 11, which is an appropriate number of classes to use, you get a suggested class width of 11.4 minutes. So what we'll end up doing is we'll actually round that down and we'll use a class width of 10 minutes. Going back to the shell that we'll use for our frequency distribution, we can actually fill in the wait time classes. So our first class will be 10 to 19 minutes. Our second class will be 20 to 29. Our third class will be 30 to 39. And our last class will be 130 to 139 minutes. And then we'll count the number of observations. For that first class, we'll count the number of observations less than 20. The second class, we'll count the number of observations that are more than 19. So if it's more than 19, it'll include 20. And then, of course, up to or less than 30. Our third class, we'll count the number of observations that's more than 29, but less than 40. And then for our final class, we'll count the number of observations where the wait time is more than 129 minutes. So that'll pick up those that are 130 up to 139 minutes. An important formula that we'll use in Excel is the Countif function. It counts the number of observations that meet a desired criterion. So for instance, let's say that we have our variable between cells B2 and B1142, and we want to count the number of observations less than 20. We'll use a Countif formula. So it's equals Countif parenthesis B2 colon B1142. So we're telling Excel where we want it to look for the data, comma, and then a quotation mark. And yes, the quotation marks are necessary. Less than 20, close a quotation mark, and then close a parenthesis. Then when you hit return, Excel will tell you the number of observations in that data range that are less than 20. We'll also use the COUNTIFs formula, and that counts the number of observations that meet multiple criteria. So for instance, we might want to know the number of observations where the value is more than 19 and say less than 30. So here we use the COUNTIFs formula where it's equals COUNTIFs, so that's plural, parenthesis B2 colon B1142, then a comma, then a quotation mark, greater than 19, close a quotation mark, then another comma, then B2 colon B1142, comma, quotation mark, less than 30, close quotation mark, then close parenthesis. So here we're telling Excel we want it to look in the cells B2 to B1142 and tell us the number of observations that are greater than 19 and less than 30. Now we can go back to our frequency distribution and actually put in the formulas that we're going to use. So to count the number of observations with a wait time of between 10 and 19 minutes, we'll use that Countif less than 20 minutes. To count the number of observations between 20 and 29, we'll use the Countifs, plural. So we'll count the number of observations that are greater than 19, less than 30. If we want to count the number of observations with a wait time between 30 and 39 minutes, we'll use the Countifs, again, plural, for greater than 29 and less than 40. And then our last class, where we want to know the number of observations with wait times between 130 and 139 minutes, we could just use the good old Countif B2 colon B1142 greater than 129. The reason we can just use the Countif here is because we know the maximum value is 135. So really, if you count the number of observations that are greater than 129, it's giving you observations that have a wait time of 130, 131, 32, etc. But it goes only as high as 135 because that's the maximum value. Now we'll jump into Excel, and I can actually show you how to use these Excel formulas, and then ultimately I'll show you how to make a histogram. So I'll see you in a sec. Glad to see you made it into the spreadsheet. Here you see a data set with some wait times for the Space Mountain roller coaster. Make this a little bigger here. You can see the month, the date, the hour, the minute, the temperature, when the wait time was recorded, and some variables that measure the sky condition. Now we're going to focus on the wait time, and our first order of business is making a frequency distribution. We need to figure out an appropriate number of classes to use, so we'll use the rule of thumb 2 to the k greater than or equal to n, and the sample size has, here we are, 1,141 observations. This is row 1142, but of course the first row has the label. So let's try 2 to the 10th power, see if we should use 10 classes. 2 to the 10th power gives us 1,024, which is not greater than the sample size. So let's try equals 2 to the 11th, and that gives us a value of 2,048, which is larger than the sample size. So 11 is the smallest value for k, such that 2 to the k power is greater than or equal to the sample size. So let's think about maybe using 11 classes. Then we need to figure out the class width. So we need to figure out the range of the data equals max of values in the j column. That gives us 135. What about the minimum? Equals min. The values in the j column is 10. So we can see here the range is 125, but if we want to get fancy, we can say equals max in the j column minus min in the j column, and that gives us a 125. If we take the range and divide it by sort of our suggested number of classes, we can get an idea of class width. I'm going to say equals the value that's in L5 divided by 11. And that gives us a suggested class width of 11.36 minutes, which will round down to 10. It's just easier to work in time intervals of 10 minutes. So I can get rid of this here. So we'll start to make our frequency distribution. Wait time, number of observations. So we know the minimum is 10, so we'll make our first class 10 to 19. Our second class 20 to 29. Third class 30 to 39. 40 to 49. 50 to 59. 60 to 69, 72, 79, 82, 89, 100 to 109, 110 to 119, 120 to 129, and then finally 130 to 139. In this last class, we'll capture the longest wait time, which is 135 minutes. So now for the count of observations, remember we'll use the Countif, and then we'll use the Countifs formulas. Equals count if the values in J are, remember we need to put in a quotation mark, less than 20. So this will count the observations between 10 and 19, because 19 is less than 20. We get 118 observations. Here we'll do Countifs. Countifs, the values in the J column are first greater than 19, so that would capture 20 above, but also the values in the J column are less than 30. So this will give us the number of observations with wait times between 20 and 29 minutes. Here we go, 76. Now let's count the number of observations with wait times between 30 and 39 minutes. Equals count ifs. The values in the J column are greater than 29, and the values in the J column are less than 40. There we have 109 observations. Now I'm just going to try to quickly go through and do the rest of these here. 39, 250, 49, 260, oops, 49, 260, 59, 270, 69, 280, 79, 290, 89 to 100. We're almost there. 99 to 110. 109 to 120. 119 to 130. And then for this last one, we will count the number of observations that are greater than 129. So we'll change up the formula here. Equals count if the values in the J column are greater than 129. That gives us 130 and above, and that's 14. So just to make sure we did things right, let's take a sum of all of our counts here. We get 1,089. So of course we have some missing values that make up the rest of our sample. So I'll do equals count if, in the J column, you have the word closed. And there were 52 observations. So if you add 1,089 and 52, you get our sample of 1,141. So we did everything right here. Now let's make a percentage frequency distribution table, which will just take a second here. This will be percentage of observations. We'll take the value that's in M4 and divide it by the value that's in M18. That gives us about 11% of the observations. We'll center that here. And we don't need that much precision. So I'm going to copy and paste this formula. But the key thing is I want to put a $sign in front of the 18 so that it'll freeze that value. Now when I go to copy and paste this formula down the column, that M4 will update. It'll change into an M5, M6, M7, which is what we want to calculate the percentage of observations. So I'm going to do copy and paste. And now we have the percentage of observations in all the wait time classes. And we can sum this, and it should sum to 1. All right, 100%, yes. So finally, we can actually start making our histogram. When you make a histogram, you're really making what I call a bar chart, or what Excel calls a column chart, and removing the spaces between the bars. So let's grab our data labels and our percentages. And we will say we want to insert. Gives us some recommendations for charts. And I like the look of this because this is a column chart, or what I call a bar chart. And we'll hit here. All right, so we have a good start at our histogram. As always, I like to move the chart into a different tab so it's a little bit easier for me to work with. The first thing we want to do is remove the spaces between the bars, because a histogram represents a quantitative variable where these classes are continuous. So the gap width I will move down to 0. All right, so now we have a nice looking histogram. Let's change some of the formatting so it looks a little bit better here. I will change the font to maybe 18. We'll change the font down here to 18. Let's put in a chart title. First, let's change the font maybe to, start with 20. Distribution of space mountain wait times. Oops. N equals 1141. What's the original sample size? Of course, we'll put in a note that there were some observations when the attraction was closed. We also have to label our axes. So we'll go over to add chart element, and we will add an axis title for the, we'll do horizontal axis first. Let's change the font so we can read it here. All right, so maybe we'll call this wait time in minutes. We'll get real fancy here. And we will add a label to the other axis, the vertical axis. Add a title here to the vertical axis. First, let's increase our font size call this percentage of observations. All right, so now let's go back and to remember how many missing observations we had when the attraction was closed. So it was 52. So I will put in a text box. We'll insert a text box. And we will say figure does not show, what was it again? I got a short-term memory issue here. 52. Does not show 52 observations when attraction was closed. So let's change the size of this text box so it's a little bit easier. There we go. Wow. Okay. Need to make it a little bit taller here. Oops. Accidentally moved the entire chart. So we don't want to do that. So let's move just our... There we go. All right. So this is a pretty nice looking histogram, if I say so myself. We have a nice descriptive title. We have our axes labeled. We have the note about the missing observations when the attraction was closed. And most important, we don't have any gaps between our bars.